Hi, in this video I'm going to talk about relationship of exponential and logarithmic function. I'm going to review all the relationship of exponential and logarithmic function. So as at first you have to go through how to sketching the graph of exponent and logarithmic function in my video before you look at the relationship here. So the first thing is exponential and logarithmic function, there is a relationship. So I try to find the inverse, so I'm going to inverse of the fx here. So I let the f inverse equals to y, right? Or I said y equals to f inverse of x. So then you know that the fy will be equal to x, right? Fy will be equal to x. So then you're going to replace the y inside here. This is the way you're finding the inverse, right? So e power y will be equal to x. So your job here is to change the y become your subject so that you can get the inverse. So the only way we do is by putting ln both sides, right? We're putting ln both sides here, right? So then you're putting the y here, then you have ln e equals to ln x. Ln e, you know that ln 1 will be 0 and ln e will be equals to 1, right? So then you have ln e is 1, which is y equals to ln x. So what is y? Y is the inverse of x, which is ln x. Now you can see that the inverse of an exponential function will be the logarithmic function. So this is the first relationship here. So relationship of exponential and logarithmic function, the first one will be the inverse of the exponential function will be your logarithmic function, and the inverse of the logarithmic function you will get back the exponential function. Alright, so you can see that, okay, I can sketch the graph for you. So for example, you have to know that the first thing that you have fx equals to ex, and your f inverse of x to be ln x, right? So the relationship also is when you have you have fx, f inverse of the f here, inverse x here. So it means you find the composite function of these two functions, you will get up to be you will get a x here. So you will get f inverse of x. So f inverse of x will be ln x, right? Ln x. So you're going to put the ln x into your f, into an f here. So you have e ln x. As you know that e ln x, you are getting x, right? So can you see that you're getting an x here? So it means that they are inverse to each other, right? They are inverse to each other. So it's the same thing also. It's f inverse here. So if you have f inverse of the fx here, so then you find f inverse and the fx, your fx. So fx will be e power of x, right? E power of x. So you put this one into the inverse of f. So inverse of f here will be ln e to the power of x, right? You put this one into this e power of x, e power of x. Then you can take down the x because this is a ln, right? It's a logarithmic function. You can, and the ln e will become 1, and you have getting the x also. So it means that these are inverse to each other, right? It's further verified that these two is the inverse of each other, right? So okay, this is the concept about you by using the composite function to verify that they are the inverse function. So this is to find the inverse function. So, and another properties will be as you know that fx equals to ex, the domain for fx for exponential function is always negative infinity to infinity. You have to refer to the video that I talk about exponential function so that you are very clear about what is happening here. So for the range of f, it will be always 0 and above. It's always positive because y equals to ex. And the ex is always greater than 0. It's always positive. So it means that the y always greater than 0. 0 to infinity. And for, okay, this is the domain and range for fx. So for the inverse, the ln x here, the ln x. So if you find that the domain, if you look at this one, the domain, right? So domain for logarithmic function, the value inside the ln have to be positive, right? X more than 0. So this one tells you that the domain of f inverse will be 0 up to infinity. Alright, 0 up to infinity. And for the range of f inverse, for logarithmic function, in my video that during I sketched the graph of a logarithmic function, I have already tell you that the range for f inverse is always negative infinity to infinity. Okay, what can you find out about these two functions here, the inverse here? So you look at the domain will be the range, right? Can you see the domain of f will be the range of the f inverse, and the domain for f inverse will be the range of f. They are interchanging, right? The range here will be the domain here. The domain here will be the range here, right? So this is also one of the properties here. So it means that the domain of f is the same as the range of f inverse, and the range of the f is also the same as the domain of the f inverse here. So if you see that, because these two is inverse to each other, that's why the domain and the range, they are interchanging here. So this is the third properties here. So whereas the domain and the range of f inverse and the domain of f inverse and the range of f are the same. This is another important properties here. Alright, and the last one, the properties here will be, if you're sketching both of the graph, alright, if you're sketching both of the graph, for example, you were sketching the fx equals to ex, right? As you know that the graph for y equals to ex will be looking like this way, right? So they will be intercept at 1. Okay? You can refer to the video about sketching the graph of y equals to ex, and the graph for y equals to ln x. For ln x, the graph will be the vertical asymptote. This will be horizontal asymptote will be y equals to 0. And for ln x, the x have to be greater than 0. So it has to be x greater than 0. So the graph will be looking like this way. They were intercepting at 1 as well. So if you look at these two graphs, exponential, it will be horizontal asymptote, which is y equals to 0. And for ln x, this will be your x equals to 0 will be your vertical. 1 horizontal, 1 vertical. And this will be the x-intercept 1, and this will be the y-intercept 1. So actually, these two graphs, if you draw properly, or you go and plot properly, they are actually symmetrical about the line y equals to x. They are symmetrical about the line y equals to x. So this is another properties where the graph of fx equals to ex and the graph of f inverse equals to ln x, which these two is inverse to each other. This will be the inverse of this, and this will be the inverse of this. So therefore, you look at the graph, they are reflecting about the line y equals to x. They are symmetrical about the line y equals to x. This is another properties, the relationship of exponential and logarithmic function. So these four, the first one, you find the inverse. You must know how to find the inverse of an exponential function and logarithmic function. And secondly, you have to know that how to verify that these two inverse and exact is inverse to each other, right? Inverse to each other. So if they are inverse to each other, they will be getting a x, right? They were getting x. So for number 3, the domain and range. This is the number 3. This one very important, alright, very important. And this one also very important, where the domain are interchanging and the range. And this is symmetrical about the line y equals to x. Alright. So okay, I will do another 2 more video about the relationship of exponential and logarithmic function.